So inside of our main activity here, as of right now, we're going to be fixing this very shortly. I have to fill up my array of patients with a whole bunch of stuff as placeholders, right? That way my list view can show some stuff. Then I'm going ahead and grabbing some things here. I'm going to go ahead and just start gutting a couple of things from this just to clean it up a little bit. I get my custom array adapter that I need for adapting my array of patient objects to my specialty row I built, right? So I had to teach it with the get view thing how to map those two together. I set the adapter for that guy to it. And then we started working with Firebase here. So I have a little function that I wrote. So I just happened to hide my function inside of core. All right, so that's not a problem. So this is core.listen for database changes. I could have called that elephant if I wanted to. So if we go into core here, here's my listen for database changes function that I wrote. And this guy creates an object that comes with Firebase called a value event listener. Basically, you're saying, I want to listen for events associated with values at a certain reference. Okay, so I'm overriding two functions in here that it requires us to override. So this is kind of like an inline version of what we did for our custom array adapter. Our custom array adapter, we created our own custom class, right? And then wrote all the stuff in there. Here I decided, you know what? Instead of creating a completely custom class for this guy, why don't I just redefine a couple of things of the default class? So I actually don't have like something called my special value event listener here. I'm using a normal plain Jane value event listener, and I'm augmenting it by replacing a few of its local methods with my own version of those. That makes sense, the difference between those two? All right, you will actually find this syntax like this pretty often, and this is not just for value event listeners. You'll find it for all sorts of different things in Java. You'll find syntax that looks like this all over the internet. It's pretty common. For instance, if you've looked at some older Android applications when you did one of your Google searches or something like that, prior to us having that on-click property for a button, you maybe have seen them do like a on-click listener. So they'll grab a button, from our from the interface, just like we do now. Where's my main guy here? I've lost. Oh. So I go to main activity. So just like we're doing right here, grabbing our list view, they would grab a button and then they would set that button's on click to a on-click listener. Okay, so they would set up an on-click listener for that guy. And it would look very similar to what we're looking at right here. Does it really have to be these numbers? Does it have to be that huge? Can I shrink just that part? Nope, apparently not. Well, whatever, deal. Okay, so it would look very similar to this type of thing, where we're just inline changing a couple things. So what I'm saying in here is I want to do something special when the data in the database has changed. So what I'm printing out here is this data snapshot, which I think I just showed this at the end of class. We didn't talk about snapshots yet, right? That's kind of where we are. Okay, so I'm printing it out, so we'll see what that guy looks like. It should look like a bunch of JSON right now. And then I'm looping through this, but I didn't talk about this either. We'll talk about that today. Okay, but basically what I'm doing is I'm saying, here's the data snapshot that the database gave me. This is what it currently says it looks like. And this guy will happen once when the application first launches, because I told it to. So what I'm saying here is when I told it right here to listen for database changes inside of my onCreate in my main activity, that will come in here and it will start this code. And where I'm saying I want core.myref, I'm going to add a value event listener. and the value event listener is the guy I just wrote up here, this PR listener. So here's a variable called PR listener that is of type value event listener, but I went ahead and just kind of augmented my value event listener here with some extra stuff, okay, or with some more custom stuff. All right, now just to remind us, our ref here, core.myref, is keeping track of my patients table or patients directory, however you want to think about it, inside of my database. And if we go look at the database here, so here's our database. We have this thing called patients, and inside of that I have several records. So we can think of this as kind of like a folder or a directory. And inside of that folder, we have 3 subfolders. And then inside of each of those subfolders, we have some pieces of information. All right, makes sense how it's kind of organized? All right, so what I'm saying here is I have a specific reference here called myref that is specifically pointing to my top level folder in my database called patients. And then when I come down here and I set an add value event listener to that guy, I'm saying, let me know about changes specific to patients. I can have 30 other references that point to different places in my database, and I can set up value event listeners for that as well. Make sense? So this allows me to focus in on a certain part of the database and say, I want to know when stuff changes here. Okay? But an important aspect of the value event listeners is this will fire right off the bat. So it'll assume that it'll kind of treat it like your database changed right off the bat. So it'll give me a full database dump of that folder. So I can populate my list view if I wanted to. And we're going to do that. Okay, does that make sense? So I don't have to, if I just run this right off the bat, we'll just open up our logcat here, and you should have seen this in your homework. All right, I have this data change thing that shows up there. Let me just go into patient record real quick so we can see this stuff pretty easily. So I have a function inside of patient record called display. I'm just going to throw some asterisks in front of that so I can filter for it in logcat so we can easily see it. So whenever a patient record displays itself, it will have some asterisks in front of it so I can filter in here. So I'm going to go. Yep.
What does the get children do again?
I haven't talked about it yet.
Oh, sorry.
All right, so I'm just going to do that. And we're going to talk about the details of this today, what's happening. I'm just going to show this to you right now. So I'm going to go ahead and run my application, and you'll see that inside of main activity here, one of the last things the very last thing I do in onCreate is I say listen for changes. Without me touching the app, you're going to see this code in here fire, showing me the current state of the database. All right, so it fires one time right off the bat, giving me my current data in case I want to do something with that, like populate a list view or that type of thing. Okay, so let me go ahead and run this guy. All right, so it's running here, but notice down here, I think I can, didn't I figure out I can zoom this? Ha-ha! So here's where it says data changed, and here's the pieces of information that it got. I haven't touched the app. All right, so this was an initial dump from the database saying, this is what I currently have. Future calls from this guy, so let me show you. I'm just going to go over to my database itself, and I'll change the name here to Michael. So I changed it there. Come back out here. Notice it changed again. and there's the Michael. Make sense? Okay, but notice it gave me everything at that endpoint. All right, can that make sense how that works? All right, so I haven't touched my Android application yet, right? Yet stuff is happening to this guy. It happened once automatically, and again, because I have this listener that's constantly sitting there listening to changes to that patients folder, if I make changes in here, it notifies automatically my app, telling my app to update itself for the new stuff. Okay, but it's giving me a full dump of that endpoint, of the patient's endpoint. All right, so questions about what it's doing right now. So we kind of make sense what the value of that listener is for. Allows us to detect changes in our database. So what we're seeing is the real-time nature of Firebase. In real time, when I change something in the database, interested parties over here in the app become notified automatically. Did I introduce the observer design pattern? I did. You didn't say uh-uh? You lied to me? Shouldn't you be studying my class just as much as 370?
She just doesn't care about you.
That's how I'm feeling. Yeah. I'm glad we're on the same wavelength here. Yeah.
I don't care about you done with the quiz
I thought it's a test.
or the test. Whatever that is.
So you're basically saying what I'm doing right now is just a waste of time. Everybody's mind's in 370.
No.
It's like, absolutely. Show of hands, how many of you are reviewing your 370 notes on your laptop right now? So just truth in advertising, I'm not going to feel bad when you ask, like, when you have trouble on the next assignment because you didn't pay attention today, is what I'm saying. So as long as we're in agreement here. Like I said, I get paid either way.
I was going to rewatch the videos too. So
I can listen to YouTube with the phone.
It doesn't upload properly.
I think I fixed that. The problem was they were all uploading. I was forgetting to tag it for the 300 playlist.
Oh, really?
Yeah. So she was asking me, said the certain video wasn't there. So I re-uploaded it and it kept getting deleted because it said, I fixed it now. They should all be there now.
Okay, I'm going to double check.
Okay, but she would say, oh, well, a certain video, it says it's deleted. Well, it was because I kept re-uploading the same video. I would tag it correctly the second time. But YouTube would detect that, hey, you've uploaded this video before. I don't know where you put it, but you've uploaded this video before, and it would delete it. So I just go and find the video and make sure I connected it to the 300 playlist, so you should see more videos in the 300 playlist now.
YouTube tried to take it down because it wasn't family friendly.
I have had that happen before.
Seriously?
Not a family-friendly thing, but I got hit with like a warning for copyright infringement. One time I was doing a tutoring session for a client who is in Miami, and so I was recording the lecture, but he wasn't there. So I was like recording it and giving it to him because he needed it, but he wasn't able to attend the actual session. Well, I happened to have a movie playing in the background. Okay, no video, but it heard the audio and flagged it as a copyright infringement because I had the audio of that movie in my video.
Their system is.
Well, I mean, it's better safe than sorry, right?
Yeah, I guess.
And then you have another video where you just have the video of the movie and play them both at the same time.
You're going to want to put these in two separate windows. Or what you do to fake it, you have it offset just a little bit for the, you actually play the audio track twice. Okay, but you split it so you get half the audio and half the audio, but interweaved. And then you tell the people how to time it to start the, to start the two YouTube videos like offset by like 13 seconds or something like that, so that when they're both playing together, you hear the actual audio.
That's actually good.
And then it wouldn't get flagged. Problem solving. All right. Okay, so as a reminder, observer design pattern says it's a good idea to be productive while you're waiting for some event to occur. All right, so our app can be off doing things. We can be clicking and hitting buttons and all sorts of stuff in our app. And as soon as that database changes, this code will get notified. This on data change code. Why? Because I attached this value event listener to my reference. And I said, I am specifically interested in events that happen to the patients folder. That make sense? So let me know whenever those happen. I'm not going to sit here and wait. Instead, I'm going to go and let my app do its thing and all this other crap. But whenever it happens, you let me know, and I'll deal with it. Okay? Does that make sense? So that's what the observer design pattern says. It says it's a good idea to be productive while you're waiting for something to happen. That's just reasonable in regular life, right? Okay, we're just seeing an implementation of the observer design pattern. We've seen it a bunch of times already with buttons. Do we just sit there and stare at a button waiting for it to be clicked? Or does a button say, hey, I want to be notified when the user clicks this button and then I'll execute this function? That's how it's worked all along, right? Our code doesn't just lock up until the button's clicked. You can scroll through, do things in your app, and as soon as you actually hit the button, then that code gets called. That's an event. Make sense? Go ahead.
I was curious, if you went back to the full screen, the value event listener had the semicolon at the end of the double brackets. It's brackets.
Yeah, this guy, it's because if you look at the syntax for how we're doing it, this is typically where we would have a semicolon, but we are actually augmenting it and saying, by the way, here's some stuff I want to override in you. So we're kind of tacking it onto the end there, like overstuffing our suitcase type thing. And then there's that final semicolon. Okay, so exact same syntax. We just did a little, freewheeling there, freewheeling there at the end. Okay, so let's talk about data snapshots. And what I want to do here, I am printing out the snapshot. So let's open up Logcat and take a look at that. Oh, the snapshot itself does not have. It's there, I just don't have asterisks in front of it. There, I'll just throw some asterisks in front of that guy. And I'll run it again and we'll get our data snapshot. And we'll see that that guy itself looks like JSON. All right, so here is our data snapshot. So remember, JSON is a collection of key value pairs, right? Okay, so my first key is called patients. The value is a JSON object. Make sense? This JSON object is a bunch of name value pairs. Here's the name, here's the value. What kind of animal is that value? Int, char, or JSON? Just look at it. It's JSON, right? It's a dictionary. It looks like a dictionary. Okay, but that's JSON. So this is JSON inside of JSON. So a JSON object is a collection of name value pairs. Values can be all sorts of things. They can be ints, they can be strings, they can be chars, they can be JSON objects. So my value associated with this crazy looking unique ID is this JSON object, which is our representation for our patient record for Blaine. Okay? Data snapshots are JSON objects. That makes sense? So if I were to print out this data snapshot dot get value, what it's going to do is it's going to show me just the value portion of this top one, which is this JSON right here. Okay, I'll go ahead and let me clear this and I'll run it again. So we're trying to look at how do you unpack a data snapshot. So a data snapshot will be in JSON and it'll be all the information you've asked for. So notice here what it gave me. It gave me a JSON object, which is actually a collection of JSON objects. So comma delimited, name value pairs. Here's the name, here's the value for the first one. Here's the name, here's the value for the second one. Here's the name, here's the value for the third one. I think that's all I have in there is 3, right? Does that make sense? Yep.
So is it the name and the values is called data snapshot? So there's 3 children there? Is that what you said?
There's 3 children inside of this one, but a data snapshot is a synonym with JSON.
Okay.
They mean the same thing. So data snapshot is our way of viewing the JSON that's coming from Firebase. Okay, most of our modern NoSQL databases, they store their stuff as JSON. Okay, so this is just showing me that I'm actually getting JSON. Now we talked about, I believe we talked about, did we talk about serialize and deserialize? So we talked about implementation of serializable, which means that we can take our object and turn our object into JSON, right? And then, yeah, here's our, oh, that's patterns of communication. Where did we talk about deserialize, or I just say it out loud? Well, let's just add it.
No,
Let's
you
just-
say it when you have the Marshall thing.
Yeah.
Yeah,
Did that not make a slide?
It's right, it was right there, last slide.
That one.
Oh, thank you. Yeah, so working with data, we serialize data, which means turning our objects into JSON. We deserialize, well, turning our object into some sort of data text-based format. Usually it's JSON. Deserialize, or the historical name for this is called marshalling. We turn our JSON, or string-based representation, back into an object. Okay, so both directions. So we serialize to send it to Firebase. We deserialize when we grab it from Firebase and turn it back into an object. That's what's happening right here. When I'm getting a value from our data snapshot, and I'll unpack what's happening there, but the data snapshot that it's looking at is, here's the value of that child. It's a JSON object. I deserialize that JSON object and turn it back into a patient record class, which is a class that implements serializable. Make sense? All right, so that's how we go the 2 different directions. My patient record here, right at the very top, we said that this guy implements serializable. That means I can serialize him and I can also deserialize him. He's set up to move to JSON and move from JSON. All right. So what am I doing here in this code? Well, we've seen our top level data snapshot. That top level data snapshot says, I have a key called patients and here is all your patients. Okay, which is a comma delimited list of name value pairs. Now, if we look at our database here, here's my patients. This is the first guy. Now here, we'll see there's 3 of them here, right? There's my 3 objects. So my patients is the name. The value is collection of name value pairs. The first name value pair has a name of this crazy thing and a value of this JSON object. This second one has a name of this crazy thing and a value of this JSON object. Third one, name of this crazy thing, value of this JSON object. Make sense? So how I'm unpacking this in code is I'm showing you the full data snapshot just so you see what the JSON looks like. But now I'm saying I'm going to take that top level data snapshot and I'm going to get his children. What does that say? Get me these three things. Here's my top level data snapshot. I want the children of that data snapshot. How do I know there's children? Because his value is a collection of data snapshots, right? His value is a collection of JSON objects. So I'm telling this guy, give me all your children, which will be a collection of name value pairs. Make sense? It just so happens that the values are also JSON.
Question.
Go ahead.
What's the difference between get children and get value?
Get value gets the actual value at a name value pair, which would say, give me this piece. Here's the name, here's the value. This guy here, patience, that's the name. His value is not something that is a direct value type. His value is a collection of name value pairs. So if I want to get that collection, if I asked this guy for his value, I wouldn't get something usable. The value of patience is a collection of data snapshots. I don't have access to data yet. I'm not deep enough in. So because I recognize this particular guy as this variable name is equal to a collection of data snapshots, I have to get those child data snapshots. The children of a data snapshot are data snapshots. So I have to ask this guy, give me your children. In this case, he has 3 children. So in my code here, I'm saying, so for each data snapshot, I'm calling it DS, in this collection of data snapshots, the children of this guy. So the first time through, DS will be equal to this data snapshot. The second time through, it'll be equal to this data snapshot. The third time through, it'll be equal to this data snapshot. Okay, so I'm saying for each time I go through this collection of data snapshot children, I want DS to be the next guy in there, however many there are. There happens to be 3 this time, but there could be 1,000. Okay? So this for loop says, I'm going to go through the collection of data snapshots that is stored inside of, in this case, patience. And what I'm going to do is for each of those data snapshots, so the very first one is this data snapshot right here. The name is this crazy thing, and when I ask for his value, I'm going to get this serialized version of a patient record. That's what this does right here. I want to get the value from that particular data snapshot. Get me that serialized version of that patient record. And then I'm letting the data snapshot know that, by the way, that is a serialized version of patient record. And what you're passing it there is you're saying, look, from this guy's perspective, that's just a JSON blob. When I say get value, that's just a JSON blob. If I want him to put him back together, if I want him to deserialize him into an object, I have to tell him what rules he's playing by. So I'm telling him that JSON blob there is actually a patient record. So when you give me the value of that guy, here is the blueprint I want you to follow for when you reconstruct him, when you deserialize him. So now ds.getValue, passing it this information about the format of that JSON, will allow me to retrieve the actual patient record object from that. This is the result of deserializing it. Because ds.getValue is JSON. It's a data snapshot, which we've said is a synonym with JSON, right? And I'm saying turn that JSON, deserialize that JSON back into a patient record, following these rules from the patient record class. And the patient record class is right here. We've set this guy up as being serializable. We gave him a bunch of public fields, which make him, so now it can say, oh, well, I'm going to have a first name piece, a last name piece, a middle initial piece, an age piece. Those are the things that I'm going to have because we've told our data snapshot that information. Okay, we've said data snapshot, I want you to get the value from your current JSON. And by the way, here's those name value pairs you should expect. A first name, a last name, a middle initial, an age. So that what he'll do is under the hood, he will create a blank patient record. So he uses this guy used for deserialization. He'll create an empty patient record and then directly set these 4 public fields. Does that make sense? Okay. And I am kind of feeling a quiz on this exact material next class. So at the very least, rewatch the video. All right. So understand. Feeling what?
I feel like you speak really well slow because I watch your video with double speed. So I'm like,
I get the same thing when I listen to my audiobooks at triple speed. So when my wife complains about it when she's in the car and the book is going, I'm used to the book going like chipmunks. It sounds like they're speaking like slow motion. Well, good, then you should be able to pick this stuff up quicker then, right?
Are you able to do it at triple speed?
You train yourself. You start off at like 1.4, and then you bump to 1.8, and then you start going to 2, and then you realize you're losing stuff. And then you kind of have to finally train your mind to get up there. And now 2 seems pedestrian to me.
like 2 is
Wow.
like a regular speed to me right now.
Mm-hmm.
Do you lose like the vocal inflection towards stuff?
I would say no. Anything faster than 3, you sort of do.
Okay.
But at 3, it's still mostly there. All right, so we understand what's going on here. So this guy goes through, let me put an extra space in here. Each JSON object contained within the top level data snapshot and turns it back into a patient record. Make sense what it's doing there? So grab the value from this particular patient record. If I were to say ds.getKey, that's going to give me this crazy looking dude. That's the key. Oh, sorry. This is the key. This is the value. All right. So if I were to ask this data snapshot to give me the key, it'll give me that crazy looking unique identifier, which actually might be helpful. And you're going to see why I say that sooner rather than later. Because when I want to go and change a value there through my code, I'm going to need that key. So we're actually going to end up storing the keys inside of our patient record soon. Because what if I have a patient record that I want to make a modification to? Instead of going into the actual database and changing Mike to Michael, what if I want to do that in my code? I'm going to have to change the value that lives at patients some crazy key. Here's that patient record that I'm updating. I'm going to need to somewhere have that collection of that key, have that information stored somewhere. Okay, so what I'm getting at here is this is not useless information. We're just not using it right now. Make sense? And it's pretty important that we built those keys to be unique because we might need them again. That's kind of like getting at the unique user ID of somebody. When you have your credit card charged on Amazon, you definitely want it to, if you aren't using Amazon. You don't want somebody else to charge your credit card on Amazon, right? So you don't want them to just randomize a user ID and say, well, we're going to use this guy's credit card today, right? You kind of want your purchases to belong to your account. So it's going to go and find the payment options for the person with your specific unique user ID on Amazon servers and then get that stuff. All right? So this is a pretty important piece for us. But right now we're just working with the value at that key. Okay? So data snapshot. Put it in our notes here. This is a JSON object that has a name and it has a value. Values can be, and let's see, I think I still have that screen up here. And this is an important thing for us here. We can have arrays, we can have booleans, we can have bytes. All right, let me actually let's just type them out so we have them. Array, boolean, bytes. Date and time. Floating point. Lat long for GPS stuff. Int. Something called a map, which is JSON.
Oh,
Null. A reference, so this is a path to another. So we're going to call this dbref, so a path to some other place in your database. Or a string. All right, these are the things that we are allowed to store as values associated with names within a data snapshot. All right, well, the very first thing we saw was we stored a string. We just stored hello world, I think the very first time we ran this. Now what we're doing is we're storing maps. So map in Java is the same thing as dictionary is in Python. And these guys are both object representations of JSON. So when you want to program, when you're writing your code and you're working with JSON stuff, you kind of like just saying, give me the value for first name, right? Instead of going through and writing code that parses through some JSON formatted string. So if we're dealing with code, we like to use maps or dictionaries for working with JSON data. If we're storing it somewhere, we want to serialize it and store it in its JSON format that we can then easily rebuild it into objects. Understand the power of JSON? That's why JSON looks the way it looks, is it conveniently allows us to store information about an object. This has everything to do with object-oriented languages. If we look at any object we ever build, let's just write it in here. What's an object? An object is a collection of fields collection of constructors, and a collection of methods. Right? Constructors, this is logic. Methods, this is logic. So that's stuff that gets run each time. Correct? Your fields, this is data. That's the uniqueness of one object versus another object. If I have two patient record objects and one's name is Mike and the other one's first name is Blaine, The thing that differentiates those two objects from each other is the data contained within them, even though both of those instances have a display method that does the exact same thing. It displays the first name, followed by the last name, followed by the whatever. Does that make sense? So the uniqueness of our objects in any object-oriented language is the data. This is the uniqueness of our objects. What does JSON do? JSON allows us to store that uniqueness as a collection of name-value pairs. Does that make sense? That's why JSON is so powerful, even though it's just a string. It just happens to be formatted in a very specific way. Okay? And then what we're seeing here is a subset of rules that says, from Firebase's perspective, here is the kind of values we will allow you to store in JSON. All right, when you serialize data to store it inside of, well, even if you don't serialize it, even if you just have a name value pair, okay, you can store a string, you can store a byte, you can store an array, you can store a JSON object, which that's what we're doing right now. It's saying these are the types that we allow. That makes sense? The most powerful one here for us, though, is this one that says map. Because that says we can store anything that is a object, in our case Java, that implements serializable. Anything that we've set this up to for him to be serialized, we can store him. Provided his fields are one of these other guys, including another object. You can have an object that contains two fields that are other objects, as long as those other objects are serializable. No problem. So then what you would have, if you looked in your database, you'd have a name, you'd have a value, and let's say this guy also had a collection of children. Maybe he has an array of actual children, human beings, right, that belong to his family. So family members. Say we have a value, we have a name called family members whose value is an array of other possibly patient records, because a child would be a similar patient record type thing, but they're attached to this patient record. So you can have values associated with these names so here's a value that's an int, here's a value that's a string, here's a value that's a string. Here's a value for middle initial that's an int. Why did I make that an int? Go ahead.
Well, we talked about last time was since it's a char, the JSON doesn't like the unsigned, well, the signed.
Are chars in this list?
They're not. So.
Not in that list.
Okay,
So can't store it as a char. So my option is to store it as a string, possibly. Right? I could say, well, your middle initial is B. We're just going to store that guy as the string B instead of the char B. That would work. Or we could store it as the integer version of the char, because we happen to know, as computer scientists, that chars are actually represented as ints. Correct? And that's what I'm doing here. So when we look at this guy in our database, we see that the middle initial here is 66. And if we look up Unicode or ASCII 66, click, that's a B, which is my middle initial. Go ahead.
Just from a storage perspective, I know it's minute, but would it storing it as an int be smaller than a string?
Probably, but then you got to follow up with another question: is storing it as an int smaller than a small string? Because now we're talking about a string with one character in it. I still think so. I think the amount of overhead it takes to organize strings, to make strings work, would probably be less efficient than an int. Yeah, usually if you're asking the question, is this cheaper than any primitive type? the best you're going to get maybe is a tie. Realistically speaking, and I actually don't even know the answer to this, we may not actually be storing it as an int. Well, actually, we are. We are storing it as an int, I believe. Let me look at my code here real quick and see how I dictated it. Yeah, I have my age represented as an int, but I return it as the char I'm not age, I'm sorry, middle initial. I have my middle initial stored as an int, even though when I print it, I'm getting its char version. If I wanted to be most efficient, I would store it as a byte. Because Firebase supports bytes, right? And actually, uppercase letters. What's the range of uppercase letters? And because the largest byte we can have is 128, or 127 rather. It's negative 128 to positive 127. Does that cover all of our alphabet? I think so. I think lowercase letters are in like the 40s, 50s, in the beginning of the 60s. No, uppercase are in that. Lowercase is like 90s and early 100s. I think it'll all fit. So if we wanted to be most efficient, we could store it as a byte, because now it's only taking up 8 bits of space. All right, but as a general rule, if you're asking which weighs less, some object type or some primitive type, the best you're going to run into is pretty much a tie, right? You know, a tiny string versus a 32-bit int, you're probably talking those guys as being pretty similar, but strings can be 5,000 characters long. Now it's bigger than 32 bits. Go ahead.
So are you talking about like the ABC and then like the capitalized of ABC thing?
Yeah.
How about someone's from Chinese and their characters is not ABC?
Well, then you wouldn't want to store it as a byte, because it's going to be a different Unicode character. I don't know where that is in the...
So it's still in Unicode.
Oh, yeah. I mean, Unicode is 65,536 of your favorite symbols. Pick your language, it's in there somewhere. It's almost pick your language. I'm sure there's some, African languages that, aren't represented, but it represents many, many, many languages. So with that in mind, your safest bet would be an int, because actually your most efficient safe bet would be a short, which is a 16-bit sign number, so that's negative 32,768 to positive 32,767. Actually, short wouldn't work because you actually need 0 to 65,535. So your most efficient safe thing would be an int, which can hold negative 2.1 billion to positive 2.1 billion. So you got some wiggle room on either side, but 0 to 2.1 billion can easily hold 0 to 65,535. So that's your safest number that will handle your people with Chinese middle names and all that stuff. Make sense? Okay, but big picture for us here is we're storing middle initials as integers here, but when we actually get the middle initial, where's my get middle initial, I'm returning a char because I'm casting that int to a char. So in code, I'm working with it as a char when I print it and things like that. But when I store it, I'm storing it as an int. Why? Because Firebase doesn't support chars. Make sense? It's as simple as that. Firebase dictates what kind of stuff you can store in there. Chars are not one of them. Okay? If you wanted it to look cleaner, and this maybe goes back to your point, Austin, storing it as a string might actually be preferred, because then when you are, especially since you consider the original goal of our modern NoSQL databases isn't about storage space, we're just going to say we have tons. So that way, when you go and look at this, we don't see this random 66 sitting here. We would see the string B. Does that make sense? So that would probably be preferred from a human being perspective, regardless of the size. You might, at some point, you would probably make the argument like, look, I'm not going to hold a 40 megabyte data value here as opposed to a tiny primitive. But if we're talking 64-bit difference or something, it's 64 bits. Who cares? Store the string. Move on with life. Go ahead.
Also, is there like, I'm guessing not, but is there a cap between each like unique ID between between the size of it? So like if you have someone's first name who's ridiculously long and maybe it doesn't matter. But
What do you mean cap? So like,
well,
is there a maximum size of the string?
yeah, other than this max size of a string.
I doubt it. I don't know for sure, but I mean, it's just data storage. So, I mean, it'll just impact the total amount you're storing. But my guess is the size is probably size of int. So you can probably have 2.1 billion characters. If I were just pulling a number out of the sky, I'm guessing strings are implemented as their length returns an int. I mean, if you look at the string type in Java, when you call its length method, what it returns is an int. So that means the number it's returning is not bigger than 2.1 billion.
It's a long first name.
But not an infinite length first name.
Right.
Not an infinite length.
What about 1 million?
Huh?
On whatever the supported data types, they have like the max.
Oh, for Firebase?
Yeah.
It just says about 1 million?
There's 1,048,000. So there's, yeah.
Bytes.
What it is.
Well, yeah, so then we got to take that, because that's in bytes, and our char types are actually 16 bits. So we're going to take that, and we're going to divide it by 2, which will get us double bytes. And then we'll divide that by... So that is the number of chars that it can hold. 524,243 chars, which is a really, really weird number. I wonder where they're getting that limitation from. Oh, it looks like 1 megabyte. Yeah, that has to just be an artificial limit. They're just saying that's what we'll store. Because that's not a power of 2, so that's not a computer science rationale. That's just Firebase saying that's the size of the bucket. Yeah.
What if someone has like 2 middle names?
Well, then we better make a better object. Yeah, our limitation here is not Firebase. Our limitation here is we wrote an object called patient record that says every human being, every patient record has a single middle initial. So pick your favorite middle initial. Okay. Or if you want to be more flexible with your object, have an array of middle initials. But if I'm a doctor at an office, I probably just say, well, I have 9 different middle names. Pick your favorite one. That's your middle initial. We're not going to use it anyways.
Well, isn't it a lot of like government documents and stuff like that? You only do get one option for middle name, so they probably already have come across.
Yeah, but I'm just saying that's the programmer's option. If you want to be able to store, an infinite number of middle initials, we can make a linked list of middle initials that we store here and move on with life. We haven't talked about linked lists yet, but that's an arbitrary size array. That's what we're gonna be doing next. So you can make it work, but we can always just say, well, what if? Deal. So you get one middle initial in our objects. So pick your favorite one or make one up. Okay. So does this make sense what this guy is doing? All right. So now if we think about because I think our code currently works where if I go in and I say I want to add a patient record, and I say Mike, actually we'll put my brother in here. How old is he? I think he's 39. No. So now he's entered in here. And then we go to our database here. We see we have a new dude here. right? All right, so we're already writing to our database. We're serializing and writing to our database. If we actually want to populate our list view with our stuff from our database, we're only one little step away, right? All I need to do is come into my code here. We look at core. What does this guy currently do when we add a new patient record? So right now, adding a patient record also writes it to the database, right? Well, we definitely don't want to rewrite the things that are in the database back to our, if I read in Mike from the database, I don't want to write it back to the database again and now have a duplicate record, correct? So what I'm going to do here is I'll just create a second version of this guy, static void add patient record local. And this guy will take in a patient record PR as a parameter. And then what I'll do here is I'll just take all that code from there and put it in there. Okay, so this is what happens. This is what's required to add a local patient record, right? And then to add a patient record to the database, I'm going to go ahead and call core.add patient record local, passing it PR. So I just split my logic into two functions. So this is what it means to add it locally only. This is what it means to add a patient record to the database. So what I can actually do is I can highlight this guy. I think this should work. I'm going to right click. I'm going to go to this thing that says refactor. Have you talked about refactoring yet in software engineering? Okay, well you will. I'm going to go up here to rename. And we're going to call this guy add patient record DB. Oh, sorry. Refactor, rename, add patient record DB. Okay, so I did that. Now if we go to our add patient record activity, notice it changed the name of that function here. So refactoring is a software engineering technique where you can, when you change something in one place, it changes in all uses of that to make it convenient for you to make those changes. So now when I create a new, brand new local, well, if I use my app to create a patient record, it's going to add a patient record to the DB. And what does that mean? It means first, add that dude locally. So he shows up in my database, or he shows up in my list. Then it says, go ahead and write him to the database as well. As opposed to add patient record local, which just says, we're going to do all this stuff. All right. Now, as we write it right now, what's actually going to happen is we're going to be redundant. Because when we add that patient record locally, what it's going to do is it's going to update our list view. When we write it to the database, that's going to create a change in our database, which is going to happen up here. And right now, I am reading all these things in from here. I'm just printing them out. But I actually have a real patient record here. Can't I just add that to my array? I have an array of patient records that my data, that my list view is showing, isn't it? Can't I take each of those and just add it to it and have them show up? I mean, that's what my guy does, right? That's what this dude down here actually accomplishes. When I add this patient record to my array called the patients, and then I increment my number of patients, that's what he does. So I can actually, up here, if I want to add my patient record local, every single time this guy does a dump, it's giving me my entire database. Correct? So rather than telling this guy to display itself, what I can go ahead and do is right before here, I can say core dot number of patients is equal to 0. Zero it out. Then I can say core dot add patient record local PR. And that'll start adding it at bucket 0, overwriting the things that are currently there. So then what I might do is down here, when I add a patient record to the DB, I might not add it locally. You're relying on an active internet connection, but I can choose not to add it locally here. Instead, when I write it to the DB, that will then trigger this code. And what does this code do? It resets my patient record array and then goes through and fills it up with all the patient records that are in the database. And then what do I do after I've done that? Core dot, what's the name of my, oh, I don't have that guy up here. Well, here, we'll write it this way real quick, and then I'll update the thing. I'm going to do it. Oop. All right, so right off the bat, we run this. We should have our list view populated now. Just needed to move that in order for it to populate, because I'm not actually resetting it, but it's populated now. Okay, so it has our actual stuff from our database. Then if I go and I add another dude here, then go back here. The new guy's not there yet, but if I move this and then scroll it back down, he is right here. This is the new guy I just put in there. Actually, is that the new guy? I don't remember what age I put. I think that's the new guy. Yeah, it is. That's right after David. All right, so I can do that. Now, if I want it to automatically update for me, I need to give myself access to this adapter here. So rather than have my patient record adapter AA stored inside of main activity, I'll put it inside of core. I'll make this guy public. And then down here, I'll say core.aa.set notify. What is it? Just notify? Notify dataset changed. I do. And then in here, in main activity, this is no longer AA, now it's core.aa, and this is core.aa. So now when I run this guy, I won't have to scroll to get it to show the data. It'll just be there right off the bat. Where's my compilers? I must have a little stupid thing somewhere. I'll look and see where it is. But in any case, that's what it'll do, is it'll finish updating that. I'll push this, so for Tuesday, bring your code up to date so that it automatically fills up your list view with your basketball players. and then automatically update your list view with your basketball players from the database. That make sense? All right, I will see everybody on Tuesday, and I'll fix this real quick before I push it.
Farther down on the page.
It must be probably another place where I'm saying AA. Yeah. So this is core.aa. It's already getting called on restart anyway, so it actually would work coming back.
Do you know why once my app comes up and then I push an app patient, I put in my information and I push add, it stops?
Well, so when you,
See,
so that's calling that's the code for your button, right?
yeah.
So look at what your button's doing,
Okay.
and then look at those lines, and then, if you want, you can put print statements after each of those and see where it's dying, but somewhere in there, it's not doing what it's supposed to do.
So I actually got bye everybody.
Yeah, so see, now you can see we have all the data is already here without me touching the app. So I'll commit.
Also, we have 2 weeks until spring break, so if we still want to do the midterm before.
Yeah. So okay. Yeah, let me know. Remind me next week sometime, and we'll figure it. No. Let's see.
I don't know why you keep saying no.
Huh?
I don't know why you keep saying no.
Well, I just want to be honest. Dated for.
You should be nicer. According to Dr. Locklear, we need to be civil.
You don't think I'm nice? I had a grad student last night. I was over at their house for dinner, and he told me that I'm mean and Dr. Locklear's nice. That's what he said.
No, but according to